Hey guys, Mr. Mises here, and I'm going to go over with you interpreting rate graphs. So what I have right here is a graph of the rate at which rainfall comes down between midnight and 6 a.m. So what we're going to do is we got to remember that this graph is a rate graph, and it's a graph of the rate of rainfall. So if you think about this, the rate of rainfall is like, anything that's a rate is the derivative of the rainfall. So we're kind of talking about the derivative of rainfall. We'll keep that in the back of our mind as we go through some of these problems. So write a complete sentence to explain what point A, what does this point right here represent, and include our units. So what does that point represent? That represents the rate. So at 3 a.m., it is raining at a rate of 1 inch per hour, right? Because that's, again, the rate at which it's raining. Okay, so what's the slope of the graph between point A and B? Well, in this slope is 0, right? We're talking about the slope of this graph. So what does it mean for that slope to be 0? Well, that means that there's really no change in the rate at which the rainfall is going. So between 3 a.m., I don't know why I keep wanting to put a period right there. Between 3 a.m. and 4 a.m., there is no change in the rate of rainfall, because it stays the same, right? Okay, so then what is the slope of the graph between points B and C? Well, notice here that this looks pretty steep, right? Looks pretty steep, but really we're just going down. What are we going down? We're going down 1 unit and over 1 unit, so the slope is going to be -1. So, I mean, it looks really steep, but it's not. It's just, it looks steep because we have 0.2s here and 1s here on the horizontal axis. So, write a complete sentence to explain the meaning of your answer in example 18. So, between 4 a.m. and 5 a.m., so between 4 a.m., again, with the period there, I don't know why I did that. Between 4 a.m. and 5 a.m., the rate of rainfall decreases, right? Because we're talking about the rate. That's what this graph is. It's going to decrease at a rate of 1 inch per hour per hour. Or you can say 1 inch per hour squared, but 1 inch per hour is fine. Okay, so let's take a look now at some other questions here. And I drew the graph again so we can see it. Shrink this a bit here. Okay, so now we're finding the integral from 3 to 5, which is the area under this graph. So we're just going to use, so we're looking for this. I'll go ahead and just use, I'll just cut this like this here. And I'll find this area and the triangle. Okay, so the area is 1 times 1, which is this area here, plus 1/2 times 1 times 1, which gives me 3/2. So what does that mean in context now? Well, remember that this was the rate graph, right? So if we're finding the integral of rate, then we're just finding the rainfall. So in this case, this is, let's say between 3 and, sorry about that, between 3 and, between 3 a.m. and 5 a.m. the total rainfall was 3/2 inches. Okay, so we had we had 3 halves or 1.5 inches of total rainfall between 3 a.m. and 5 a.m. So remember, we're talking, so whenever we take the integral of a rate function, we're finding the accumulated amount of stuff. So it goes back to our spam stuff, accumulation. Okay, so we're going to, next for number 22, we're going to approximate the value from 0 to 6. Now 6 is 0 here. We already know that this part right here, that piece is 1.5. This is a curved value here, so you know what we'll do is we'll just go like this. All right, we'll make a triangle, and I'll find the area of that triangle. That's a, you know, it's good enough approximation for us. So that's 1 times 3 times a half, right? That's the triangle, plus 1.5. And that's going to give us 3. All right, so write a complete sentence explaining the meaning of example 20 for number 22. Okay, again, now we're saying for the rain, the total rainfall from midnight to 6 a.m. was 3 inches. Okay, so we had 3 inches of total rainfall. Okay, so that's an example of dealing with rate graphs and looking at the accumulation with definite integral, or looking at what is it telling us in terms of its slope. Okay, all right, that's it, guys. See you later.